Is it something what? Trig always pops up here, there, and yonder, but.
No, but I don't like it.
When this says tan lines, it's not the trig tan. If that makes you feel better. It's just a tan, yeah. It's, yeah.
I like tan. I have a really big tan.
All right. Because we're going to have a good time with these tan lines. Okay. What? This is Miss McGee Good Times. Yeah, this is Miss McGee Good Times.
Oh, so it's not student good times. Oh.
I'm going to call this f of x. Because I want to, and I can't.
I'm actually taking notes today, but
Brother, you might want to write some of this down.
all right.
This line, the green line, is called a secant line. Again, but it's not the trig secant, okay? So don't start freaking out on me. It's a secant line because it passes through the green one. Okay, it's green on my end. It looks a little like light blue on that one.
That's not science.
All right, a secant line passes through 2 points on the graph, okay? So that is the definition of secant line. You'll hear us say secant line a lot, okay? That is as opposed to a tangent line. What? Yes. No. Whereas a tangent line is a line that passes through the curve in exactly one place only. Yep, tan line. Now, we've kind of talked about this before whenever we started talking about instantaneous rate of change, right? Y'all remember whenever we started talking about how we wanted to know the rate of change at an exact point where we talked about Armando throwing the rock off the cliff. And we tried to get the distance between to be 0. That was my h. Do y'all remember that? Do you know what I'm talking about? We said the distance between the 2 points would be h, and we'd try to get that to go to 0. So essentially what we were doing was we were trying to find the rate of change at that point, okay? Which is what we call the slope of the tan line. So we'll get to all that in a minute. Let's focus on secant first, and then we'll move into tan. Yes.
Wait, which one is Oh,
that's exactly right. The slope of the secant line is arc. The slope of the tan line is iRock. Do you see why?
Yes.
Good. Yay. Y'all were ahead. Okay. I feel like they've all and then there's like a lot of.
Yeah.
All right, so this is my slope, right? This is just f of b minus f of a over b minus a for my arc, right? But for my iRock, my slope of my tan line, that's where I have, do y'all remember we have to do that limit, right? We do the limit as h goes to 0 of f of a plus h Or that could be an x. We can do x if you'd rather do x. It doesn't matter. But this being the specific point, minus what? F of x or f of a all over h. Okay. Notice I said tan line. We're going to be writing the equation of a line, but the first thing you need for the equation of a line is the slope. So this is how we're finding the slope. So we're going back to that thing we did on the very first day with that instantaneous, that IROC and AROC. That's exactly right. So let me show you an example. This, by the way, is the first time we give this its official name. This is called the difference quotient. Generally, they will use an a with it instead of an x, so they'll say f of a plus h minus f of a over h, but that is the difference quotient. No, it is. It's the difference quotient. It's the formal definition. This is the first time y'all will hear this word too. Of a derivative. Okay, that's the first time you'll hear the word derivative. We're finally getting into a look. Yeah. Peyton is excited. All right, but for right now, we will find this derivative. We will find this difference quotient this way using the limit as h goes to 0. So let's look at a couple examples and let's see what we got. This will be a little more algebraic for you, Lane.
Oh, yeah.
No what? Oh.
Stuff that doesn't make sense.
Find the average rate of change, which just means AROC on the interval -2 to 0. Mark, set, go. Exact answers, no calculator.
How are we gonna go?
Calculator. Get used to leaving things like that. Like, I don't need to know what e to the second power is. I can leave it. Just like I can leave the square root of 2 as the square root of 2 because it's irrational. I can leave e to the second or whatever it is. I can leave it that way because that's a perfectly acceptable answer. Okay, so AROC just means what? Slope. Oh, wait.
I don't know this right.
So this is just slope, yes? F of -2, which is e to the -2, which I'm actually going to do 1 over e squared. And then f of 0 is 1. So now plug into that AROC formula, that slope formula that you learned back in Algebra 1, right? I do y1 minus y2, so 1 over, we'll say AROC equals 1 over e squared minus 1 all over -2 minus 0. Okay, so one thing you do have to get, this is where I always say you get bogged down in the stuff that's not actually calculus, it's the algebra behind it, right, Rhett? Because if I need to simplify this fraction, now if I'm on an FRQ, I'm okay to leave it just like that. But if I'm on a multiple choice scenario, I need to be able to work this a little bit. Work it. What's that? So, they always do that little cheer. Anyway. Tell Malaya I did that. Okay. So I get a common denominator up top. This becomes 1 minus e squared over e squared all over -2, and then I can just multiply by the reciprocal there. Now, would you have to do this every time? Not necessarily, but you do need to know how you can manipulate it to get it into a simpler form. so that you can recognize that if that's one of your options. I would say that's as simple as it gets for that one. They may even would break it up. I don't even know how it's formatted in. You could split this up since it's the adding and subtracting is up top. Negative 1 over 2e squared plus e squared over 2e squared, which would be 1 over 2. It just be able to work with it should you need to. You see what I'm saying? Yeah. What? Because you killed kitten. You're talking about right here? Right here? You'd still kill a kitten. Because of that minus sign right there. Well, it's just the two things multiplied together. When I broke it down. I split up the fraction. I did this over this. I mean, this minus this. But yes, it was a negative divided by a negative, so I just made it positive. A-Rock. Yes, no, maybe so. Maybe so. Do another one. Lane, this one's for you. You ready?
That was not for me.
This is number 5 on your homework. You'll see a lot of things we do. We call them something else, but it's things we've already done. So yes. Some of them. I need to make y'all a copy of them too. Yes. Yes.
I honestly barely remember it. Hold on. I got more so many. I would sell it. Did not do one for the first one.
All right, so if I'm doing A-Rock here, right? So, yes, it is. F of pi over 4, which would be cotangent of pi over 4. Now, remember the over 4s are really nice because they're the same values, right? It's root 2 over 2, root 2 over 2. You just have to figure out which one's positive, which one's negative, and where. 3, this is pi over 4. Where is 3 pi over 4? What quadrant am I in? In the second quadrant, right? So here's 3 pi over 4. So here my tangent value is 1, and then if I flip that over for cotangent, it's still 1. Over here, my tangent value is -1. Flipping that over is going to give me the same thing as -1. So cotangent of pi over 4 is 1. And then cotangent of 3 pi over 4, 9 times out of 10, they're going to give you fairly easy values like this, which is -1, right? Now all I have to do is plug into A-Rock. So A-Rock, and I'm going to write it like this, A-Rock on the interval from pi over 4 to 3 pi over 4. We use a lot of subscripts in here where it will help us distinguish from one thing to the other because you might be finding A-Rock on 2 different intervals. And so that I remember which A-Rock I'm looking at, I might do a little subscript down here just to kind of remind me that that's the interval I'm finding A-Rock on. And so I do y1 minus y2, or vice versa, divided by pi over 4 minus 3 pi over 4. Notice this is still not really calculus, right? This is just average rate of change, which is just slope. All right, so I got 2 over, what is pi over 4 minus 3 pi over 4? Negative pi over 2, or negative half a pi, right? Because you have negative 2 over 4, which is a half. I'm going to multiply by the reciprocal, and so I get negative 4 over pi. Is that what you got? Uh-oh. Did anybody get, oh, it's negative 4 over pi. Y'all see where you messed up? You see what happened? I'm going to guess it happened somewhere here whenever you were subtracting those.
I get it.
That's, yes, that's going to be the, let's apply this a little bit further then. I'm going to pull this is number 7 from your, so I'll do 7 and you'll have 8. They look almost exactly the same, but just to show you how we're going to keep doing the same thing and we're going to call it something else. Please let this work. It's not a microphone at all. How do I get to it now? Oh, I put a little link up here. Yay! Bless you. I don't want y'all to see the answer. I mean, it really doesn't matter. All right, so the first part of this says, in exercises 7 and 8, a distance time graph is shown. Estimate the slopes of the secants. So I've got 1, 2, 3, 4 different secant lines here. Okay, each of them start with P and they go to varying Q's here. And they want to know the appropriate unit for these. So I'm going to kind of slide over here to the graph so you can see it. Here's my P. So they said P1. So can you kind of see the secant line there? Let me get a pencil so I can draw it. Remember, secant means it goes through what? Twice. 2 points on the line. So they asked me to find the slope of secant line PQ1. So this line, the slope of that line. Then they asked me PQ2. So then it's going here. Then PQ3, then PQ4. Okay. So let's run through and see what happens here. This might be easier if I just write. Ready? Okay. Notice your units on here. Seconds. Oh, y'all can't see that, can you? That says seconds and meters. Okay. All right. So let's do PQ1. PQ1. Remember, it asked me to find the slope of PQ1. The slope of the secant line. That's gross. There we go. So, I need to know the point P, and I need to know the point Q1, right? Say right, because that's right. Okay. P is, what are the coordinates of P? 2650. And what are the coordinates of Q1? And we can kind of estimate it. 10 to 20. I think I'm going to go back to my Miro board because this is messy. Y'all have this on page 97 in your book.
97?
Yeah. What? Not the book, but what I ran you. Yeah. Yeah, it's on page 97. All right, so if I use those 2 points, I said it was P 2650 Q1 was 10 to 20. I'm going to go ahead, I think, and write all the coordinates just so we can kind of reference from there. Q2, what does it look like that is? 14, 75. How about Q3? 17, 480. How about Q4? 15. Oh. Okay. We all in agreement with those points? We don't have to be exact on these. They're going to be a little bit different here, there, and yonder, but that's okay. We're just using them when we're kind of trying to make it a point here. So each of these represents, connecting it with P is going to represent a different secant line, okay? So we've got secant line PQ1, secant line PQ2, secant line PQ3, and secant line PQ4. I'm using all these crazy words and I'm making this sound like I'm doing something way more complicated than what I'm doing, but at the end of the day, really all I'm doing is what? A rock slope. That's it. I'm going back to algebra 1 slope. That's all I'm doing, but I'm using fancy words to say it, okay? So don't get lost in all the vocabulary there and everything that's going on, because at the end of the day, I'm asking you to do something really simple, okay? So let's do the slope of the first secant line. So I'm going with this point and this point. Ret. I don't even know what you're doing. Maybe you should stick with the calculus. All right, 650 minus 2, what'd y'all get? What is it? 43. Oh, look at y'all, meters per second. How did you know the units to use here? Because units are very, very important. The graph said it, and I'm talking about a rate. And look, the top were my meters, the bottom was my seconds, and then I know meters over seconds, meters per second. That's always how you can remember the rate. It's always the units of y over the units of x, okay? How about, what if I took this one step further? Now we could keep going. We'll keep doing this. We'll keep doing the secant. Do the secant for the last 3 points. Y'all do it, and then we'll look and check together. I'll do it too. Are the units changing on any of these? I heard yeah and no. The units are the same, that's right. But the actual values are changing, right? Let's see. If you round, make sure you go out at least 3 places. If you don't go out at least 3 places on the AP exam, you lose your answer point even if you were right. I always go 4 to double check because I'm paranoid, but always go at least 3. 3 is their rule. So if you round this one, I would probably use it. I would probably keep it as a fraction because I'm paranoid again. But if you do round, you would need 45.833 to to make sure you pick up your. How'd I what? Oh, I'm sorry.
Well, when it was 75 last year, I tried to,
Is that not right?
no, I put in the wrong number.
Oh, okay.
Oh, never mind.
This one would be 56.667. I was gonna say, where are you boys on that one? Rhett's too busy with his calculator batteries back there. But Thomas was at least doing this. And then the last one, 100 over, oh, so it's just 50 meters per second. Let me take this one step further. You ready? Now I'm going to take it back to Algebra 1 again. Yeah, actually, I think this would have been. Write me an equation for the secant line PQ2. Give me the equation of the line, the secant line PQ2. Mark said that.
Taking is A rock.
Uh-huh.
So it's really just.
How you write the equation of a line? Line. We're going back to line, linear functions. Okay, if I've got a slope and a point,
So then it's
we will use this point slope form until you feel like you are going to throw it up.
Yeah, I didn't.
Okay, so if you don't remember, it's okay. Remember, or if you don't remember, it's okay. Remember, no. But M is the slope, and x1, y1 is any point on the line. And I can always use this to represent a line. We will use this for secant lines and tan lines because it is easy. Okay, less room to mess up. So what I'm going to do, because I'm going PQ2, here's 1 point. Here's another point. So I have 2 points. I really only need 1, but I have 2. And I also have, I've already found the slope of that secant line. So there's the slope. So the equation of this secant line, pick whichever point you want. Which one do y'all want to use? 14. Okay, Rhett says 14. Y minus 375 equals, the slope we found was 275 over 6. X minus 14. You are okay to leave it there. Most of the time, the only thing they want you to do with this is solve it for y, but you don't have to simplify or anything like that. In other words, I just need to move that 375 over and have 275 over 6, x minus 14. We don't. We never use that again. No, it would have been fine. Yeah. So you could, did y'all hear the question? Did it matter which point we used? Would we have gotten the same thing? And you would have. So the other equation would be 275 over 6, x minus 20, and then it would be plus 650. Either one of those would be the same. Nope. Too much. Okay. If you don't remember point slope form, remember it. It's going to be, you won't have any choice but to remember it soon. Yes, Armando. Well, secant and tangent, we haven't touched on tangent yet. We've just done, right now this has just been, so I'm going to show you.
I got it.
That was a hard one because of all the different secant lines there. And they don't ask you to, let me show you. All right. IROC does take a while. No, I think I want to do this one instead first. I want you to write an equation for the tan line. Now, I need to tell you where, right? Because tan lines involve instantaneous rates of change. So in order to write the equation of a tan line, if it's at an instant, if it was average, I'd give you the span, but since it's tan, I need to know when, right? Tell me the exact point. So write the tan line when x equals 1. We'll go easy. Now, before you do this, understand what it is you're finding, because I find if you can visualize it, it kind of helps you better understand it. This is a parabola that is upside down and shifted up 4, yes? Say yes, because that's right. Okay, thank you.
So we need that, right?
Huh?
So like, you know,
The difference quotient? What?
They give you
Yeah. Yeah. Oh, no, that's just for velocity when you're falling off a cliff. That's because that's the force of gravity. That's why that one always. Now we're branching out from that a little bit. All right. So understand what this means. All right. For at the point when x equals 1, what is the point? What is the corresponding point on my graph when x equals 1? In other words, what is f of 1? 3, right? Because it's 4 minus 1 squared, which is 3. Is anybody confused about that? This is foundational. We will do this up through the very last section in calc. Like, this is tan lines never, never, never go away. All right. 1, 3, and we always do them the same way. Rat! That was my way of saying shut up and pay attention. Okay. I'm finding the equation of the line, and there is only one that will go through this graph at that point. Just that one point. And that's what it looks like. That's the tan line.
So we don't use this.
Everybody on, yeah, we will.
Oh.
All right, this is the tan line. This is the tan, but a curve has an infinite number of tan lines, boys. This is the tan line at 1. There's also a tan line at -1, right? I could come here. There's a tan line. There's a tan line here. There's an infinite number of tan lines. I'm looking at the tan line at 1. The instant x is 1, so it's instantaneous. Okay? Is everybody with me? All right. What do you need to write the equation of a line? A point and a slope, right? I have a point. Do I not? What is my point? 1, 3. What am I missing? A slope. Because it's a tan line, I use IROC. That's exactly right. So IROC is that difference quotient. So here's the calculus part of it. This is the first time we've touched calculus with this problem, okay? You ready? To find the slope, I do the limit as h goes to 0 of f of, but I know what my x value is, right? It's 1. So it's f of 1 plus h minus f of 1 over h. Yes, you can use that value. So when I'm working difference quotient, I generally come off to the side and work the little pieces because I like for my work to be nice and neat. If you want to work it within the problem, that's fine too. It doesn't matter. But if I'm having to square and stuff, I always come over here and say, okay, well, what is f of 1 plus h? It's 4 minus 1 plus h squared. I just find that I make mistakes whenever I carry it through the, but you do you. You do it however you want to do it. So this is 4 minus, now this is twice, so it's going to be 1 plus 2h plus h squared. I'm just kind of foiling that out in my head because there's a, no, Armando? Okay.
I get it. I was wondering we got the right step. Or,
The which one?
no,
So I'm finding f of 1 plus h. and my f of x is 4 minus x squared. That's my original equation I'm working with. All right, so this is 4. I'm going to just distribute this minus sign so you see what's going on. Oh my gosh.
That was my.
I know. I'm going to make a rule y'all have to be at your own table. Gosh. All right, so here this is 3 minus 2h minus h squared. Yes? All right, so let's plug in what we know here. We're doing the limit as h goes to 0 of 3 minus 2h minus h squared. Rhett, what's f of 1? Thank y'all for telling him. What's h? We don't know.
Zero.
I gotta make it be 0. But I gotta do some manipulation so that I can make it be 0. That's right, because you can't have 0 on the bottom. I can't cancel h's out yet. Why? I gotta get rid of the 3's first. So now I'm the limit as h goes to 0 of negative 2h minus h squared over h. And now I can take an h out. H. So now I'm the limit as h approaches 0 of negative 2 minus h. Which is, have I answered the question I was asked? No. What was I asked to do?
Find the tan line.
Not just the slope, that's what I found, the equation of the tan line. And we said for I swear, Rhett.
No, he said it wasn't.
So now I know that the slope of the tan line is negative 2. Now can you write the equation of the line? Do it. Always point slope. If you ever see the question, write an equation for bleh, and it's a line, it's going to be point slope, and start asking yourself, where can I get a point? Where can I get a slope?
Yay.
What do you think? It's fine. That's the slope.
I don't know.
You need a brain break? I got one. We talked about an equation of a secant line. We talked about the equation of a tan line, but there's another type of line that we talk about. Not all the time, but sometimes, but it's really easy. It's called the normal line. They're not normal, they're weird. All right, so the normal line, here's what it does. The normal line intersects at the point of tangency at 90 degrees. So, it is in other words, it's perpendicular to the tan line. Okay, so if I went back to that graph that I was looking at a minute ago that did like this, and this was my tan line, so this is tan, then the normal line so a normal line is just perpendicular to the tan line through the point of tangency. That's all. Why is that important? Well, if I need to write the equation of the normal line, the point is the same. Look, it's going through the same point. So remember, to write the equation of a line, I need what? A point and a slope. The point is the same as the point with the tan line. The only thing I need is I need a new slope. How do you? That's exactly right. Thomas, I'm so impressed. It's the negative reciprocal. That's all it is. So it's the tan line slope, but just flip and switch because it's perpendicular. And then you write. So if you've got the tan line, you've got the normal line. You just need to adjust the slope. Okay. So over here, if this is my tan line, then my normal line would be y equals flip and switch 1/2 x minus 1 plus 3. That's it. That's normal line. I know. All right. I'm going to give you your work. Page 97 and 98, 1 through 12, but we have already done. Uh-oh.
Alright, bro, we get it.
I'm at 7 because we did that one together. Yeah.